Hello everyone and welcome back. So let's continue. So far we've created this, and as we play through the sim, they're getting finer and finer. And the thing that this thing is bothering me a little bit. I don't like the result of the jitter, so I'm gonna remove that and create something using just a simple noise. So actually I don't need, I have one already, so I'm gonna copy this guy, I'm gonna put it in here, and let's dive inside. And let's increase the frequency, the amplitude, and let's increase the frequency to 100 by 100, cool, something like that. And now if we take a look, we have a lot of points at the center, and then as we hit play, the source is getting bigger and bigger. So let's take a look. The source is getting finer and finer as it travels through and reveals the superfine details. Cool, so the next thing I want to do is I'm gonna lower this just a tiny bit, something like that. And then we want to delete these guys randomly. So right now they're not dying at all, and I want to randomly delete each of these emitters. I don't want to delete the actual points, but I want to delete the entire stream of points. And the only way to create that is to go back to the original sim and create an identifier that we can use later. So let me turn this off. So what I'm going to do is I'm going to go back to the to here before the points goes into the pop network. I'm going to create a identifier, so I'm going to call it identifier, and it's simply equal to the point number. And this point number is going to be inherited by all these steps. So whenever let's hit play. So whenever we have the points now, they are inheriting their source, which should be a unique number that identifies them. The only thing is, with this point replicate, we have to make sure that we copy source points. And now let's create a wrangle, and let's actually make sure the identifier is there. So let's say if identifier is less than 10, we want to remove the points, just to test. Remove point of the 0 input, and then we use the add ptnum to delete the points, and that got rid of that stream. And instead of using this this explicit, I'm going to use a different expression that uses the frame number. So if the frame number is higher than a random value that we're generating using this, we're going to delete the points. So at frame is higher than, let's say, 17 plus a random value generated based on this identifier, which will be unique for each of these blocks. Now the random value is going to be between 0 and 1, and I'm going to multiply that by 4 to make it go between 0 and, the starting range is 0 to 1. I'm going to multiply it by 4 so that it goes between 0 and 4. And then I'm going to use a floor expression because the random value is actually float, so it can give me back 0.5 or 0.2. And using a floor, I'm going to convert it into an integer. And this should make the streams get deleted. Yeah, you can see they're getting deleted randomly. I mean, the randomization is not huge, and that's fine. Cool, so we have that, and let's add that somewhere here. And I'm gonna add another delete. Actually, let's use a blast node. You can see at the origin, we have points below the zero axis. So I'm going to delete that point. P.y is less than 0. I want to delete the points and delete non-selected. So now we're left with everything that is above. Cool. So we're almost there. And the last thing, let's see. The last thing we're going to do is I'm going to add a fluid source. And this is going to be my density source. So let's tweak this guy. Let's make sure it's set to source smoke, and I don't care about velocity at this point. I'm just interested in the density. So let's make sure we have that. And we need to change this to stem points because we have point inputs. And then as we scrub through, you can see it's converting those points into a fluid source. Cool. So let's lower the stem points radius to capture the fine details of our points, and let's lower the voxels. Now, in most of the setups you see, you will see that the division of the source is linked to the sim, and to be honest, it's not really required. You have to have enough data in your source that matches the voxel or higher. It doesn't have to be a one-to-one match. And in this case, I'm gonna cache it with a higher resolution and just use it independently from what the resolution of the sim is. So in this case, 0.05, let's see the resolution. Yeah, it's still not really high. It's nothing crazy. Let's take a look at this frame. I want to capture all the details of the sim, so this is still reasonable. Let's go lower. And basically what this is, it's taking these points and stamping them, and we're telling it how far to look between each point. Now these guys are adding a little bit of noise to the volume, but that's totally fine. I'm not going to worry too much about that. Let's scrub through. Cool. So I think we have a good source at this point. And this is so far only for one stream. We have to design and spend a lot of time deciding the motion of what these particles should do or should behave like. For example, we can create a ground element where these guys only shoots in this direction. We can have them shoot in straight line and then disappear. We can have some that shoots upward really high and then stops and then dies right away. We can have some that goes like this and then just tip a little bit and then dies off, and that's a different emission. And designing, and you guys have to look for references as to how you're going to use all of these. And at this point, I'm just showing you how to solve the technical challenges that you may run into. As to what you're going to design with this is totally up to you guys. Cool, so I think the density source is ready. Now, the next thing that we need is the velocity. And right now, we don't have anything for the velocity. And the cleanest way, the best workflow to actually inject velocity from a source like this is to create what we call a pump source. And basically what a pump source does, it knows where to inject the velocity. So it will use the density field as a mask and only apply the velocity where that mask is positive. So it properly knows how to inject data in the sim. And it doesn't require any sub-stepping. So even if you have a high velocity or a fast moving object, as long as you have the proper mask and everything, the pump source will work perfectly fine, and it's a very efficient method. But currently we don't have any interesting velocity vector. I mean, this guy is just shooting outward, and we can definitely use that. That's not a problem. But I want something further. I want something more interesting than that. And what I'd like to do is, at the beginning here, you can see we have a thick volume, and it's a radial shape. I want the velocity to push outward from this stream. I don't want it to push in. And as it travels through, I want to change the velocity to change its angle to push outward. And what this will help me do is basically make the bottom thicker and have the details going outward, and then as it gets higher, it's gonna spike or becomes thinner. And there is actually a very simple way of doing this. If we go back, we have this position and we have the points at this position. So what I'm going to do is I'm going to create a point VOP and connect these two guys. So here we have the points deformed like this, and then all I'm going to do is I'm going to import that second position. So import attribute from the second position, and I'm going to subtract the two. I'm going to create a vector from this point into that a deformed point. So I'm gonna do that, and let's connect that to V and take a look. And you can see we have something that pushes outward all the time because of how these points are laid out. And let's go back, and then all we have to do is we're gonna use that vector to basically create the pump source. But I don't want it to be always facing outward. Let's actually multiply this by 10 so we can see it and also have a more interesting value. You can see it's pointing outward, and as we go through the sim, it's still gonna point outward. But I don't want that. I want it to blend into this direction as it gets older. And I'm gonna apply the same trick. I'm gonna use the point position along the y-axis, so this guy here. I'm gonna do the same trick to blend between this new position and this new vector and the old velocity. So I'm gonna use a mix node to mix between this and the current velocity using this, and then let's connect that. And now as we go back here, we should see them all pointing outward. So let's make sure that that's the case. Cool, they're all pointing outward, and as we play through the sim, you will see them slowly blending into emitting, following the shape of the movement of the particle. And this is very interesting. It's going to create something more complex. Now, obviously, I'm showing you guys this idea because I know I spend a lot of time doing R&D to figure out this method, and I'm showing you the final trick. If we didn't go through this, we have to do a lot of sims, take a look at the sim, do a lot of testing, and then based on that result, see what we can do in SOPs. But right now I'm showing you all the tips and tricks I have in SOPs, and then we're going to go back in DOPS and start playing with that. But just how I come up with this, it took me a lot of time to figure out this, what's the best way to source, what's the best way to inject velocity, what's the best way to inject density, how to solve emitting from fast moving objects, how to solve emitting from 100 tendrils at the same time. And I'm showing you basically the conclusion of all of this, the best workflows for each of these scenarios. And yeah, hopefully it works out for you guys as well. So let's continue. I'm gonna add the same delete here as well, even though it doesn't really matter because we don't have velocity. And I want to also add that blend here. So let's see what we can do. So I'm gonna copy the point position attribute copy. I'm gonna copy the point position from here into here. So match. Yeah, so I'm copying the point position into here. And now we have the velocity pointing outward. Cool. Actually, we could have done it here, so let me just inject this guy. And then we don't have to do this. And the position is coming from this guy now. And as we progress through, actually we should, yeah, let me put it back. Sorry, that's not correct because the position we have here is not deformed yet. So let's put back the copy. And now let's create the pump source. So here I'm gonna change it to pump, and we have to use the same settings. Well, we don't have to, but it's a good it's good values what we've find out previously. So I'm gonna reuse the same thing, and let me change the visualization to ZX. XY ZX. I'm trying to show the values, but basically the velocity should be pointing outward. If not, then it's pointing inward, and then we'll simply multiply it by a negative value. So let's try that, make sure. Yeah, we'll try both and see which one gives us the correct result. Okay, so I think we have everything ready now. So all I'm going to do is I'm gonna dive inside the sim and connect this. And then create a null, call this out val pump, and then out density. And when it comes to fast moving objects like this, it's always good to add your own bounding box, because the sim can expand quickly. And what I'm going to do is I'm going to scatter some points at the frame 1. So let me put down a time shift. So we have the volume here. I'm going to scatter some points. That's too much, just 10 points is enough, maybe 100. And then I'm going to scatter some points on the source as they update. I'm going to combine both of them. I'm going to create a bound node, and I'm going to use this as the bound for the sim. And no matter how fast the source is going to be, we're not going to run into any issues with this. Now the source is stopping after frame 24, and that's fine. Because at this point the sim should have gone and already progressed throughout the simulation, so we shouldn't worry about having data afterward. And I'm going to put down a file cache. I want to cache these two sources because they're slow to process, and it's much faster to read them from disk. So I'm going to call this source density new dot v1. I'm gonna cache 25 frames, even though it's only 20 frames really. And then I'm gonna copy this, and let's change this to pump, and let's submit both of them. And then under the load, we have to make sure that we change this to no geometry instead of error, otherwise it will interrupt the sim. Cool, so it should be going now. Yeah, and then we'll continue in the next video and import them. Thank you guys for watching, and see you in the next one. Bye bye.